The topic of today's lesson is the MITRE ATT&CK framework. And in this lesson, we also included a detailed demonstration of the brute force system. Your task from lesson 5 to research different forms of cyber espionage would have revealed that cyber espionage is becoming ever more sophisticated and common. An interesting recent cyber espionage case in 2019 was when Iranian hackers conducted a cyber espionage campaign targeting air transportation and government actors in Kuwait and Saudi Arabia. The hackers implanted malware into an update for Orion, an IT and cybersecurity management dashboard product used by SolarWinds. By the end of this lesson, you should be able to describe the concept of the MITRE ATT&CK in the context of cybersecurity. Explain why the MITRE ATT&CK framework is widely adopted by cybersecurity companies and analysts. And as mentioned earlier, we've included a demo showing how to brute force a system remotely. If you're into cybersecurity, you would have heard about MITRE and the MITRE ATT&CK framework. Basically, MITRE is a non-for-profit American organization whose sole focus is on developing threat models and defensive methodologies for both the private and public sector cybersecurity communities. MITRE ATT&CK is a globally accessible database that was first created in 2013 to document and track various techniques attackers use throughout the different stages of a cyber attack. This knowledge base has been compiled to create a threat model for public companies, private and government agencies, and even cybersecurity analysts to use as a guide in the strategic countering of threat actors. The word attack stands for adversarial, tactics, techniques, and common knowledge. Now, since its inception, it has become one of the most respected and referenced resources in cybersecurity. Traditionally, cybersecurity personnel focus on defensive strategies as best practices, but the MITRE ATT&CK model changed that. It facilitates a more balanced approach to security by combining classic defense approaches with leveraging threat intelligence. Basically, it presents more effective ways to secure networks simply by using IOCs, indicators of compromise, for example, that detect and even remediate an attack. In today's cybersecurity tech space, adopting threat-informed defense strategies using MITRE ATT&CK will greatly increase the chances of cybersecurity analysts being able to combat cyber attacks. The core components of the MITRE ATT&CK are the following. Tactics. The tactical plans used by the threat actor during the attack. Techniques. The implementation of the goals or tactics used in different attack methods. And procedures. The execution methods used by threat actors during the attack. MITRE ATT&CK has 3 iterations, which are Attack for Enterprise. This focuses on enterprise networks, highlighting different operating systems such as Windows, Mac, Linux, and other network devices like switches, routers, and even cloud environments. Attack for Mobile. This focuses on mobile platforms, mainly on iOS and Android operating systems. And pre-attack. This focuses on pre-exploit attacks like zero-day vulnerability, which has affected both mobile and also enterprise. Did you know zero-day vulnerability is a vulnerability in a system that has been disclosed but is not yet patched? You may wonder why it is called zero-day. A zero-day attack is a software-related attack that exploits a weakness that a vendor or developer was unaware of. So, the name comes from the number of days a software developer has known about the problem. Clearly, 0. In a Security Operations Center (SOC) environment, the MITRE ATT&CK model or framework is widely used across a large number of disciplines, including threat hunting, threat intelligence, and risk management to better understand the tactics, techniques, and procedures of various threats. Now, the main reason for MITRE ATT&CK in an SOC environment is being able to fully understand the root cause of the attack, where forensics were carried out by cybersecurity analysts to search for the damage and the initial entry point of the attacker in their system. So, what is threat hunting, you may ask? It is a proactive search through networks, endpoints, and datasets to hunt for malicious or suspicious or risky activities that evaded detection. Let's explore the MITRE ATT&CK illustration for an enterprise in 2020 from the 101 Guide to MITRE ATT&CK. As you can see here, using the MITRE ATT&CK framework, we're able to virtualize the different stages of an attack. The demo at the end of this lesson will highlight credential access and brute forcing a system. This is a lot to absorb, so feel free to snap and save this table to examine at your leisure later. We will unpack each stage for you now to enable you to better understand it. The reconnaissance stage of an attack is the first and most important stage for a threat actor to launch a successful attack. Reconnaissance has to be properly carried out for the threat actor to get familiar with a target to establish the weaknesses. This stage involves fingerprinting the entire network by using port scanning to identify the main domain controller on the network. In the resource development stage, the threat actor will study the results from the first stage and then compile every resource needed to carry out the next step. This involves gathering all the documentation on the software running on the target system. The initial access stage involves the threat actor trying to gain a foothold into the target system. The threat actor would have to try to exploit the vulnerable application running on the target system by using things like phishing mails or Trojan software to get access to registered users. The threat actor needs their login credentials to create a sort of backdoor to the system. If all the previous stages have been carried out properly, the execution stage is pretty easy. This stage involves the use of CLI, Command Line Interface, to launch scripts remotely on the targets. By running scripts, the threat actor can schedule tasks and change system services to help evade detection. The persistent stage involves the threat actor sticking with a target system for as long as it takes to fully achieve their malicious plan. The threat actor needs to maintain a period of invisibility to manipulate accounts and even create a new administrative account while undetected. The privilege escalation stage is often confused with the persistent stage because there are similarities. But at this stage, the threat actor can exploit the vulnerability on the running operating system to gain elevated access to certain resources. In the defense evasion stage, the threat actor uses evasive techniques like G-access token manipulation or user group policies modification to avoid detection on the target system. Most applications in an enterprise network go through some software patches. These patches will require the threat actor to keep using these evasive techniques to avoid detection on the compromised system. Just as the name implies, the credential access stage highlights how the threat actor uses automated tools to gain user login details. Techniques used in this stage are brute force attack and two-factor authentication, etc. These techniques enable the threat actor to gain access to the compromised system and then elevates their access throughout it. The discovery stage is linked to the credential access stage in that the user login details that were collected are then used to search for either the domain controller, workgroup, or any other resources on the compromised network. In this stage, the threat actor would use the techniques such as application windows discovery, process discovery, password policy discovery, etc., to search for more details on the targeted system. The lateral movement stage is very similar to the privilege escalation stage. However, in this stage, the threat actor does not try to gain higher administrative rights, but rather uses the current administrative rights to get other user credentials. This is done by spear phishing, sending a phishing mail to employees within the enterprise network, or remote service session hijacking. The collection stage is one of the best stages for a threat actor because in this stage, the actor retrieves all the data of interest from the target system. Data that is most often retrieved includes financial info, personal user credentials from social media, and data that could be sold to make a profit. Techniques used to do this are screen capture, video capture, keystroke, so typed keywords on the target system, and collection. The command and control stage is often called CNC or C2 in the cybersecurity environment. In the case of CNC, the threat actor would have carried out all the previous stages correctly and then injected a Trojan software on the target system to enable them to send commands to the target system, either to retrieve data or use the target system as a means to corrupt other networks, as in a botnet attack. The exfiltration stage is mostly associated with industrial espionage. In this stage, the threat actor will extract sensitive information or data that could be sold to the competitor of the target network. The final stage is impact, and this may vary for different threat actors. As previously discussed, threat actors have different reasons for breaking into a system. Some are for political or social issues, and others are for financial gain. Depending on the reason, the threat actor would use different techniques in the stage, such as encrypting the entire target network for ransom, removing account access, or formatting sensitive data on the local storage of the target system. The Cloud MITRE ATT&CK table we're about to show you is an abbreviated version of the original enterprise model. You'll notice that most of the stages in the enterprise model also appear in the cloud model. This is the MITRE ATT&CK illustration of the cloud matrix for an enterprise network. Again, you can see all the stages and the techniques used by the threat actor to breach the system. Feel free to snap and save this to examine more closely at your leisure. We're now going to explore a brute force attack. A brute force attack is a cryptographic hack. Basically, when an attacker relies on guessing possible combinations of a password until the correct one is discovered. In this demo, I want to show you some attacks that are being used by threat actors. And in this case, we'll be looking more into brute force attacks. Now, in the case of looking into brute force attacks, we'll be looking more into SSH. So this demo is going to be more concentrated on brute forcing an SSH open port. So, to be able to get the username and password you need to keep in mind while we're going through this demo. For the brute force attack to actually work, you need to have a rough idea of the password and username of the system which you're trying to brute force. Because the idea of brute forcing is trying out multiple combinations of passwords and usernames and hoping one of those passwords would be the right and correct password. So for this demo, I'm actually going to be working with the Ubuntu machine and also with the CyberOps workstation. So let's get started. So the first operating system we're going to be using is our CyberOps workstation, where we will be confirming our IP address. So on the station, we simply just go to the terminal, and we type in ifconfig and enter. And what we want to note is the IP address, because this IP address would enable us to see if this machine is actually up and running. Okay, so now we have the IP address. We can simply jump back again to our Ubuntu virtual machine. So on our Ubuntu machine, we're currently seeing some updates. And we don't need to update. So I'm just going to cancel this and simply navigate to our terminal. So now we have our terminal up. The next step of action will be to actually scan to see if we can look up the workstation. Now remember, we already have the IP address. So on the Ubuntu, we can simply just type in the command nmap and space, and simply enter the IP address 192.168.56.101, and then we press enter. Now, the reason for this is because we don't want to scan for the version of the OS, so we don't include any other parameters. So we just want to know if this machine is accessible, and we can scan to see the machine. So now we know this machine is currently running, and it's actually running 2 services, and they're running on port 21 and 22. The first service is the FTP service, which is basically being used as file transport protocol, which is used for transporting files on a network. And we have our SSH services. Now we have verified an open port on our CyberOps workstation. We can use this port as an entering point to the system on the CyberOps workstation. So the next point of action for us will be, since we know how the brute force attack works, to have a basic idea of the password and the username of the machine we are trying to brute force. So in this case, we would need to actually create our possible list of usernames and passwords and save that as a text file. So simply using the command cat and an arrow user.txt. And simply just press enter. And now we can populate our usernames. Now, because we want to keep this short and simple, we already know the username for our CyberOps, and the username is basically analyst. So we will be including that name and random names just to show you how the process works of a brute force attack. So in this case, I was starting with the first name, analyst, and walking through different names. So I'm going to use Steven, and I'm going to use John. I'm also going to use Peter, and I'm using Ruchen and Edwin. So basically, I just created a list of possible usernames that could be the possible usernames to log into this machine. I simply just save this using Control-Z and stop the cat command. So if I want to verify that I have all of those details, I can simply run the cat command, cat space. This time around, I won't be using the greater than sign again. I'll just be using the file name. So I can just copy and paste on the terminal. So I have cat user.txt. And so now we can actually see we have a list of possible names that could be our username. So now we can create a possible password list for our passwords. So simply, I'm going to clear this. And we can use the command cat and the greater than sign, pass.txt. And this time we want to try our password with every possible name that we want to be in our password list. Now, the past basically just means our password. Now, we know the password for our CyberOps workstation is CyberOps. And we know that in a real-life scenario, we would not really know the password. We would have to guess it. So, in this case, we would kind of make it more difficult by tweaking in the different passwords that we could use. I will actually start by using the word book. And let's see, we want to use split. And next we want to use C-boy. And then we want to use tomboy. Next, we want to use saltbook. And now we can actually put in some different words and also use the word waster file. And lastly, we use CyberOps. Which is, of course, our real password. And simply enter and use Control-Z to stop it. So now we have one of those predefined keywords that we think that could actually break into the system. So we can actually verify that we have all our passwords listed on our pass.txt.file using the command cat pass.txt. And we can see we have a list of exactly that which we have in here. So at this point, we have successfully created our username and passwords that we want to use to launch a brute force attack on the CyberOps workstation. Now remember, in a real-life scenario, you would have bits and pieces of this puzzle, so you would probably guess the name to start with A, B, or C. It's going to be really, really difficult to do this in a real-life scenario, except if you have a dictionary and have a good understanding of the targeted user you're trying to brute force. Okay, so now that we know all about that, we could simply go back into the terminal and we can run our nmap command while associating it with script's argument to utilize our user.txt and pass.txt file we have created. So how do we go about that? So simply we can use the nmap and space. Now remember the IP address for the CyberOps workstation. So we're just going to jump in really quickly so we can actually confirm the IP address of the CyberOps workstation. Now, the IP address again for the CyberOps is 192.168.56.101. And now that we know that, we can simply jump back again into our Ubuntu and start the process. Nmap 192.168.56.101. Now what next? Remember from the previous scan we had two ports open, port 21 and 22. The port 21 was basically our FTP port, and port 22 was our SSH. Now in this case, since we're attacking the SSH port, we'll need to specify the port by simply using the -p space. And we type in the port number, which is 22 space. And next we type in the arguments. So this time around, we want to use scripts. So type in -- scripts. Now we want to specify what kind of scripts we want to use. So in this case, we want to use an SSH brute force script. So we type SSH-brute space. And this time we need to put in the script's argument by using -- scripts. And now we have that. We need to simply put in the username and password that the scripts could actually be using. So we simply just type -arg. That is the argument. And we can type our username. And we can actually type our password. So in this case, we have userdb. And the userdb represents our username. And we have passdb, which represents our password list. So in this case, you simply just type in your username list, which contains the usernames. That is the list of possible usernames we actually created earlier on. And we can simply just type in the extension of the username file. In this case, we have the username saved as .txt. And next we have our passdb = pass.txt. Now, to break down the whole command, we have the nmap, and we have the targeted user. And while specifying the targeted user, we know the set port this user has opened. And we're actually targeting port 22, which is our SSH. And we were running a script. And the script is basically an SSH brute force script. The script is passing arguments, and the arguments being passed is the userdb, which equates to our usernames and passwords. Now, simply by typing enter, we can let the process keep on going. Now, this might take a while, depending on the number of combinations of usernames and passwords we have on our text file. But in this case, because we actually made it quite easy, we can actually go through the whole list. Now, if you noticed, the previous list tried the first name and the first password, and it didn't work. Now it goes through the entire list of usernames and passwords to see which of these actually connects and opens up that port. In this instance, we see the host is still up, and the port we're trying to brute force is 22, and the service is the SSH. We can see that it's successful, and at the base, we can see we have the username and password, and this username and password has been certified to be a valid credential. Now, the reason why it is valid is because while we were running the Nmap with the scripts, there was a session being established to test to see if this password, username, and password will actually open this up. And that's why we have valid credentials. So at this point, I just simply showed you how to carry out a simple SSH brute force attack. Now, if you want to do this in a real life scenario, you should have a rough idea of the system that you're trying to break into. So what I mean by that is you should have a list of combinations of passwords being used on the system. So probably you know the first 2 letters or the last 2 letters of the password. And you can actually create a very authentic and a very strong list that would be able to brute force the system. And that is it for this lesson's demo.